Good evening, everyone. This is Mr. Humphreys here. We are going to be doing 1.3, Chapter 1, Section 3, and we're going to be solving equations with variables on both sides. Once again, this is something that you did do last year, but we're going to take it one step further and put word problems with it and do some things that are a little more complicated. So we're going to start off with a word problem today. So let's look at this. This I want you to write down in the Solve It section on page 21. It says that the following information represents the population of two towns. So we have town A and town B. We know that the population right now in town A is 3,225 people. In town B, the population is 3,300. But we know every year town A grows at a rate of 100 people per year. Town B grows at a rate of 75 people per year. So what we need to do is we need to translate this word problem into an expression. So I want you to think of it this way. Don't try to write an equation yet. I want you to slow down and just look at town A. Look at the first town. What do we know? We know that we have a population of 3,225, and we have a yearly growth of 100 people per year. So let's just turn that into like a rate or into an expression. We grow at 3,225 and we add 100 people per year. Now per year, per means multiplication. We don't know how many years. So we're just going to write this as 3,225 people is where we start at, and we're increasing plus by 100 people per year. So that's going to be X. Town B starts at 3,300 people and grows 75 people per year. So what would your expression be? 3,300 plus 75 X. Now here's the question. We want to know, after how many years will the populations be equal? I want to know when this expression, which represents town A, is equal to the population of town B. So all I have to do is make these two expressions equal. Now, if you remember how to do variables on both sides, we have to move the variable on one side. So let's move the variable onto one side. So I don't care if you want to move the 100 and move it over that way, or move the 75 and move it over that way. It's completely up to you. But I'm going to move the 75. I always like moving the smaller value because to me it's easier. So how do you move a plus 75? Well, you're going to subtract 75. Anytime you want to move something across, you have to do inverse operations. So we're going to subtract 75x. That's going to give us 3,225 plus 25x equals 3,300. And now just solve the rest. We want to subtract 3,225 on both sides. That would leave us with 25x equals 3,300 minus 3,225 is 25x equals 75. We divide both sides by 25. That gives us x equals 3. So answer the question. After how many years will the populations be equal? So we knew that x equals the number of years. Therefore, x equals 3 years. So after 3 years, the populations of both towns would be equal. Now let's look at the Got It section on problem A. What is the solution of 7k plus 2 equals 4k minus 10? So everything you should ask yourself when you see problems like this are, number one, do I have any parentheses to get rid of? I don't. Can I combine like terms over here or over here? You can't. Now the biggest mistake that I see students make is that they want to take this 7k and combine it with this 4k and get 11k. You only could do that if they are both either on this side or both either on this side. Because there's an equal sign separating them, you have to move it across the equal sign. I could take the 7k, move it over, and make it a negative 7k. I could take this 4K and move it over and become a minus or a negative 4K. Whenever something crosses that equal sign, you have to use inverse operations. So in this problem, I'm going to move the 4K. The opposite of plus 4K is subtracting 4K. That would give me 7K minus 4K, which is 3K, plus 2 equals negative 10. Now, what's the opposite of plus 2? I'm going to subtract 2. That gives me 3K equals negative 12. I'm now going to divide both sides by 3, and that's going to give me K equals negative 4. And that's my answer. Now turn the page to page 22 and look at the practice A problem number 1. In this problem, we are once again going to move the variables to one side. So we can either move the negative 3c to the right or the plus c to the left. It doesn't matter to me. However, personally, I'm going to move the smaller coefficient, which is negative 3c. Because what's going to happen is I'm going to move the minus 3c. So the opposite of minus 3c is plus 3c. That way it's going to become positive. So what's left is a negative 12. Here's a common mistake, so be careful here. A lot of students forget that this is a negative 12 and they just bring down 12. Please make sure this is a negative 12, so that comes down. Equals negative 5 plus 1c plus 3c is 4c. So now I need to move the minus 5 over by adding 5. Negative 12 plus 5 would be negative 7 equals 4c. I now divide both sides by positive 4, and that gives me the improper fraction, negative 7/4. So now I would like you to do number 2 on your own, pause the video, and then see what you get as your answer. If you do number 2, you would add n to both sides, and you would get negative 23 equals 5 plus 2n. You then would subtract 5 on both sides and get negative 28 equals 2n. Divide by 2, and negative 28 divided by 2 would give you an answer of negative 14. So the answer to number 2 should be negative 14. Let's look at the next problem, which is going to be the got it problem in the middle of the page on page 22. So let's read this together. An office manager spent $650 on a new energy-saving copier that will reduce the monthly electric bill for the office from $112 to $88. In how many months will the copier pay for itself? Now this is a little trickier because it's an equation that you have to write where something equals something, but it's a little harder to get those expressions. So let's think about what we're spending for a copier. Before the office manager spends the $650, how much are they paying per month? We're paying $112 per month. So if they do nothing, they are going to be paying $112 per month. We want to reduce that rate to $88 per month. So the question, and this is the one thing I really want you to start getting used to and do more of. It says in how many months. So in how many months, if you don't know the number of months, what are you going to let x be? The number of months. So let's think about it. Let's go back to our $112. It costs $112 per month. $88 per month. So where does that $650 go? Think about it. The office manager is going to spend $650. Where are they spending the $650? Are they going to spend it here with the $112 per month? Or are they going to spend it and then have $88 per month? You should add it to the right side because the office manager wants to reduce their monthly electric bill. So if they pay the $650, that means their monthly electric bill is going to drop to this. So this is what they're paying. So we want to know at what point will the copier pay for itself, since the price per month actually went down. So we want to know when it's going to be equal. When is this side going to be equal to this side? So we just solve it. So we're going to subtract 88x on both sides. So if you subtract 88x, you are going to get 24x equals 650. Divide 650 by 24. X equals. Now if you divide this, you're going to notice you're not going to get a nice neat number. You get 27 point and then some decimals. Well, we don't want, this is just a word problem. We just want to know after how many months. So I don't care about, 27.08, 27.1. That doesn't make sense. So in how many months will the copier pay for itself? Well, it's going to be after the 27th month. So after 27 months, the copier will pay for itself. Please make sure you always label. And that's your answer. Now let's look at the next example, which is a STEM problem. STEM means a science, technology, math problem. I love these problems. You'll understand it, but I'm going to warn you that it's almost going to trick you. It's going to be something that's going to make you think. So read it to yourself as I read it aloud. An architect is designing a rectangular greenhouse. Along one wall is a 7-foot storage area and 5 sections for different kinds of plants. On the opposite wall is a 4-foot storage area and 6 sections for plants. All of the sections for plants are of equal lengths. What is the length of each wall? So once again, let's find out what we need to find. We need to find the length of each wall. So we want to know all the way from 4 feet plus all of those 6 sections and the 7 feet plus all of those 5 sections of gardens, how long is each wall? So let me draw the picture here. So here's our picture. What do we know about each of these sections? We have 6 over here, and we have 5 up on top. What do we know about each of them? What does the problem state? We know that they are all equal. So that's what we need to find. So x is going to be each of these pieces, since they are all the same. So what expression would you write for up top here? How many x's do you have? Because what you're trying to find is this. What is the total length of this side? How many x's? 5x plus the 7. What is the length of this side? We have 6 x's plus 4. What do we know about this side and this side of the rectangle? We know they're equal. So our equation would be 5x plus 7 equals 6x plus 4. Solve the equation. I'm going to subtract 5x on both sides. You get 7 equals x plus 4. I now subtract 4 on both sides. I get x equals 3. Now here's the part that a lot of people get tricked by. This is a problem where you're not done. What does the 3 represent? Well, if you remember, each of these x's represents one of those little pieces. So we know that x is each of these pieces. So we have to take the x and plug it back in here to find the length of each side. So 6 times 3, because we have 6 3's, 6 times 3 is 18, plus 4, that's going to give you a length of 22. So the length of each side is 22 feet. So let's just check it up here too, up here at the top. 5 times 3 is 15. 15 plus 7 is also 22. So the length of each side of this rectangular greenhouse is 22 feet. Now I want you to look at the got it problem on the middle of page 23, underneath problem 3. So look at the got it problem. So now it's the same type of problem, but you have to distribute first. So let's distribute the 4. So we get 4 times 2y plus 1, which is going to be 4 times 2y is 8y. 4 times 1 is 4, equals 2 times y, which is 2y. 2 times minus 13, which is minus 26. Now I'm going to subtract 2y on both sides. That's going to give me 6y plus 4 equals Don't forget the negative, negative 26. I'm going to subtract 4, 6y equals, what's negative 26 minus 4? Negative 30. Divide both sides by 6, and you're going to get y equals negative 5. We have one last new concept to teach you, and that is on page 24. In the gray box, you can read that yourself, but basically here's what it says. I'm going to go over 2 new possible answers. You have always solved equations that give you an answer. X equals something, y equals something. But there's 2 other options for an answer, and that's this. If you have something like x plus 1 equals x plus 1, or x plus 1 equals x plus 2. Let's try to solve the first one. If I subtract x on both sides, what's going to happen to your x's? They're going to cancel. So you're left with a statement that is true. 1 equals 1. 1 equals 1. Now if you think about it, what number plus 1 is going to be what number plus 1? What numbers could you plug in for x? Would 6 work? 6 plus 1 equals 6 plus 1. Yep. Would 7 work? 7 plus 1 equals 7 plus 1. Yep. If the variables cancel and you get a number equals a number, basically you get an expression that is exactly the same as the other expression, you can stop. X plus 1 will always equal x plus 1. Therefore, this is going to be called infinite solutions. Every answer that you could plug in works. Now on this problem, you're going to do the same thing. Subtract x, subtract x. But here you're going to be left with 1 equals 2, which is not true. 1 does not equal 2. You are never going to take a number and add 1 to it and ever have it equal that same number plus 2. This side will always be bigger. So if the letters cancel, if the variables cancel, and what you're left with is a number equal a different number, you're going to get something called no solution. Because there is no solution that is going to make your equation true. So you are going to get either one solution. Every problem you've solved up until today is one solution. And then you could also get infinite solutions, which means everything works, or no solution, which means nothing works. So I'm going to do the got it problem A. I'm going to distribute the 3 and get 12b minus 6 equals negative 6 plus 12b. Well, let's look at this. Let's just look. 12b minus 6 equals negative 6 plus 12b. It's the exact same thing. And if you actually went one step further and subtracted 12b on both sides, you would actually get negative 6 equals negative 6, which is true. Because this is true, this is an infinite number of solutions. So let's look at B. 2x plus 7 equals negative 1 times 3. Whoops, let me erase that here. 3 minus 2x. I'm going to distribute the negative 1. I get 2x plus 7 equals negative 3 plus 2x. Once again, since the 2x's are the same on both sides, just look at it. Is 2x plus 7 going to be 2x minus 3? Well, they're never going to be equal. And if you actually subtracted 2x's on both sides, the 2x, you get 7 equals negative 3, which is not true. Therefore, this answer has no solution. The last thing is on page 25 in the middle of the page, tells you the summary of solving an equation.